In this video, our goal is to advance our knowledge of normal probabilities, and we want to focus on how to find inverse normal probabilities. For the first example, there's a little typo here. I'd like you to erase this part on the screen. So you want to erase that. And in particular, we just want to find the value of z with the subscript 0.05. The big question, what does this mean? Step 1, draw the normal distribution. Step 2, we're dealing with the z random variable, obviously. And so its mean or center value is 0. Then the next step is to account for what the 0.05 means. It simply means that it is the size to the right of a number that we do not know. And that number, we have given it a placeholder, which is 0.z with the subscript 0.05. But we do not know the true identity of that number or of that z 0.05. Remember, the size of this area is what we have here. So this is 0.05. So strictly speaking, it has to be the area to the right of the unknown value, here. So let's see what this unknown value is. Let's uncover the identity. So we have z 0.05, and to do that, let's go to StatCrunch. Go to StatCrunch, and in particular, I want just the standard, make sure it is the standard, and since it's the z random variable, 0 and 1 are in order here, and we want the area to the right, so make sure it is greater than or equal to. Then you set the size of the area to 0.05 and hit the compute button, and you have your answer here. To 3 decimal places, this is 1.645. So with that said, take that back. So you have 1.645. So our answer, the identity of that number, is 1.645. That is because the probability of z greater than 1.645 is exactly or approximately 0.05. You're welcome, if you get the gist of this example, to pause the video at this point in time and try to walk ahead on this. So you're welcome to pause the video, and after you're done, you can unpause the video and watch as I complete the correction here. So here we go with the solution to this question. I'm going to draw the normal distribution. I'm going to locate the center. My z of 0.01 is this number, such that the area to the size of the area to the right, strictly to the right, is 0.01 or 1%. And there is a number here whose identity we do not know. So that number, the placeholder currently is z subscript 0.01, whose identity is unknown. To uncover the identity of this number, I will go to StatCrunch. I have my mean, I have the standard deviation, and I'm going to reset this to 0.01 and compute. So in this case, this is 2.326. So that number is right here. And the size of this red area is 0.01. So I have my answer there. So I have carried over the answer right here. And with that done, we are ready to move on to the next page. In context of a problem, let's see an example. So in this example, we're told that the final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. So the final exam scores, I'm going to let that be x. Normally distributed, normal. The mean is 63 and the standard deviation is equal to 5. Question A, find the 90th percentile. What does that mean? That is, the score, X0, such that 90% of all exam scores are below this unknown number and 10% are above it. If you're a visual learner, here we go. We're dealing with a normal distribution, so I'll sketch the normal distribution. I'm going to note that the values of X, the final exam scores, are on the horizontal axis. I'm going to locate the mean, which is 63, and I am interested in finding the 90th percentile. That is the number such that the area below it, equal or below it, the proportion of all exam scores below that number is 90%, hence the 90th percentile. And so, if 90% are below it, the remaining 10% are above that number. So, with that said, this number, which is unknown, which is X0, is the unknown number. And how do I get to that? This is what I will do. I'll go back to StatCrunch. Take note, the mean is 63, the standard deviation is 5. So in StatCrunch, I'll set that up. So I have 63 and 5. And going back to my question, I would like the area below or less than. So I would go back here. I want less than, and I would alter the size of the probability. You know what? To help understanding, let me delete this. So going back, take note, you key in the parameters, 63 and 5. And I have that here, 63 and 5. And then I want the size of the probability going here, which is 0.90. Take note, 90% is 0.90. So I want that going here. 0. So I have my 0.90 here, and make sure that this is less than or equal to y, because it's the area to the left, and I have the required probability here. Oh, that altered. That is not good. 0.90. Good. Compute. Good. So you have 69.41. And right here, so the number here is 69.41. This guy is the 90th percentile. In the context of this problem, it means that 90% of all final exam scores in this statistics class was either equal to 69.41 or below. Then, for the next part of the question, question B, we are to determine the final exam scores that make up the middle 95%. Sure, we sketch our normal curve, we locate the mean, which is 63 in the context of this problem, and we want the final exam scores that make up the middle 95%. So I'm going to pick a point here, which I don't know, its true identity, and then the other point here, and the size, the combined size of this shaded region is equal to 95% or 0.95. So locating the actual identities of these two values is very important. So let's begin. I'm going to call this the lower value. I'm going to call this the upper value. Now, going into StatCrunch, what we need to do is to specify that we want to specify an area between. And I'm going to delete this, and I'm going to also delete this. Make sure that I have the correct parameters there. Very, very important. Then specify the size of the area, 0.90, and compute. And you have the two values here, 54.78 and 71.22. So the lower, again, is 54.78. Let's write that down, 54.78. And the upper is 71.22. So this is equal to 71.22. These are the final exam scores that mark off the middle 95% of exam scores. So, in the context of this problem, 95% of the students scored between these two values. With that question completed, we proceed to the next example. In this example, we are told that a random variable is normally distributed with a mean of 25 and a standard deviation of 5. If an observation is randomly selected from the distribution, we have the following questions. Before we continue, let's take down the parameters of this normal distribution. The random variable is normally distributed, so x follows the normal distribution. The mean is 25 and the standard deviation is 5. So, for question A, what value will be exceeded 10% of the time? This means if I sketch the normal distribution, I locate the center value, which is 25. I am interested in an unknown value that the percentage or the size of the area above it exceeded will be 10%. So I need to locate a number that is unknown. This what value is coming here, and the area above it is equal to 10% or 0.10. So with that said, we are ready to find this inverse problem. So I need to specify the parameters of the normal distribution. So I'll go back to StatCrunch. I'll set this to 25 and my standard deviation is 5 according to the question. Then the area above or greater than or equal to 0.10. So I am going to change this to standard and then I'm going to delete this because that's where my answer will be put. And I want 0.10. I want to specify too that this should be to the right, greater than or equal to. So the answer is 31.41. So here we go. The identity of this number is 31.41. This is my answer. Then, question B. What value will be exceeded 95% of the time? So let's sketch the normal distribution again. And we want the value that above it exceeded. That is, above it, you want 95% of the time. So we want this unknown number. So what would that number be? The mean, of course, is still 25. So in the same context of this problem, all I need to do, similar to what we did earlier, I'm going to delete this and I'm going to alter this, make it 0.95 and compute. This is 16.78. So this is equal to 16.78. The next part of the question, question C, tells us to find the interquartile range. What is the interquartile range? It is the third quartile minus the first quartile. So, in other words, if I have the normal distribution, the mean is 25, which is the same as the median, or the 50th percentile. The first quartile will cut off the lower 25%. So you have 0.25 here. And the mean or the median will cut off the lower 50%, whereas the third quartile, so Q1 is here and Q3 is here. And so Q3 will cut off the bottom, the orange part, the bottom 75% of the numbers, 0.75 rather. Okay, so that brings us to the question. What area here is strictly in the middle? This would be 0.75 minus 0.25, which is 0.50. So, in other words, we are looking at a curve where Q1 and Q3, this is the center value, and the region in the middle has a size, or this region between has a size of 0.50, which comes from 0.75 all the way from Q3 all the way down, minus from Q1 all the way down. So right in between here, you have this 0.50. So with that said, let's erase this so that it looks a little clean. We can go into StatCrunch to find the identities of these two guys, since we need them in this formula. So we go to StatCrunch, and I'm going to change this to between, and I want the right parameters. Do I have that already? Well, mean is 25 and the standard deviation is 5. So going back here, going back here into StatCrunch, I can delete this part, and I'm going to delete that part too. And I have 0.50 and compute. So I have 21.63 and 28.37. These are the values here in the first quartile and the third quartile. So now that we have the first quartile and the third quartile, I am ready to find the interquartile range, IQR, which is Q3 minus Q1. That will be 28.3724 minus 21.6276. That will be approximately 6.7448. This is the value of the interquartile range. Then question D tells us to determine two values, of which the smaller has 15% of the values below it. So we have the normal distribution, just not the best sketch in the world, but it comes close. The mean is still 25. And we are to determine two values, of which the smaller of the two values has 15% of the values below it. So I'm going to call that S. And the percentage or the size of the area below it is 0.15 or 15%. And again, the larger has 15% of the values above it. So the larger one, which is also unknown at this time, also has another 15% above it. So to find this is similar to what we did here. If 0.15, 0.15, 15%, 15% are below and above, then what proportion do we have between them? So that'll be 100% minus 15% minus 15%. So we're definitely left with 70% between them. So all I need to do in StatCrunch is to alter what I had before. This is 0.70, and I'll compute. So I have the smaller and I have the larger value, and I'm done with that question. Let's carry it over. So here on your screen, I have the smaller value, which is 19.8178. The probability that x is less than 19.8178 is 0.15 approximately, and the probability that x is greater than 30.1822 is greater than 30.1822 is 0.15, approximately 2. All right, with that said, we are ready to start looking at some more diverse questions. This will be covered in the next video.